Hola clase. We're going to start the topic of differentiation with a video in which we're going to go through the concept and get the idea. Hopefully we're going to get to something called differentiation by first principles, and we're going to do that in less than 8 minutes. Let's see how we go. So first of all, it's important that I understand the idea of what is differentiation, what I want to do. That's important because depending on what I want to do, I will have to define some tools. And then I need to know what I want to do so I can apply it. So we're going to start looking at a graph of a function, f of x. I don't know the numeric expression, it doesn't matter either. I know it's a function, I give values here of x, and the function will have different values depending on it. Right. Let's imagine that they tell me, okay, find the gradient of that function. I look at it, and to each one of these points, I could be able to attach a tangent line. If we use, let's use a ruler, I could be able to, for each one of these points, find a line that just touches, that's the tangent, and because this is not a straight line, each one of these, all over the place, will have a different gradient. Okay, so in very broad terms, that's what I'm searching for. When I derivate, I want which is the function, which is the rule that all those different gradients follow. Okay, now I'm going to just figure out 2 points. 2 points belonging to, let's go these ones, for example, that belong to that function. And I'm going to join them by a straight line. I don't know, can we see the difference of colors, hopefully? Let's change colors. Second trial. And of course you're going to imagine that's a straight line. And, well, I can then create the right angle triangle that would give me the rise over run, which is what I create to find a gradient, which is the gradient of this line here. Alright, this point I'm going to call it point P, and I'm going to leave it fixed at a certain coordinate x. Because it belongs to that function, then it's going to have somewhere here a coordinate y that is going to be f of x, of that x value. Now this point, it's not fixed, it can move. So I'm going to define that depending on x. I'm going to add a distance, h, that I will be able to change later on. So then this point here becomes x plus h, and because it will have a vertical coordinate, I can find it there, somewhere in here, and the y coordinate, if this is x of x, this could be, excuse me, this is x plus h, f of x plus h. Now I've got 2 y coordinates, 2 x coordinates, so this gradient, what I'm asking for, my derivative, I call it f prime of x. This is the original, just to mark that this the derivative, I put a prime there. Now, rise over run is just a matter of beginning changing these coordinates in there. So, this y2, this one here, f of x plus h, minus the second of the y coordinates, f of x, over first one, x plus h, minus x. Well, I see some like terms here, so I can very easily simplify here And what I'm left, my numerator doesn't change, and I'm out of the frame. And here, divided by h. Okay, now remember that I told you that this point, I can change it. And if I go, let's try to go colors, and I begin decreasing this h, this point gets closer and closer and closer to this original. So each time I join these 2 points with the corresponding straight line, I'm going to get closer and closer to the one that is just touching here this point, but without. Not quite. How close can I be? Well, let's imagine that we zoom here. Let's make this very, very exaggerated. And I've got that point here, and I could have, ideally, that's a horrible straight line, there. That tangent there. This, remember, was that point x, f of x, that we said was fixed. If I keep on moving this one closer and closer and closer and closer, eventually I want to be so close that I have the 2 points exactly in the same place. And that would be ideal. Then the gradient of that line could be the gradient of the tangent. Now, there comes the trick. Because I would come here, and it would go, well, that tangent has a gradient, it's what I'm searching, f prime of x, so I would just have to go here, f of x plus h, minus f of x, all of that divided by h. I should be able to come here, substitute, and get the gradient. What's the problem? That we say that this tiny, tiny h here, it's the distance between them both. If I make it 0, I would have a 0 here in the denominator. And I cannot have that. It would give me an infinite or an undefined. So, what's the smallest I can go? How tiny can this h be? So, these 2 points, x and x plus h, are very, very, very close, but h is not 0. Well, that actually has a name. This could need to be something so small that it's almost 0. Something infinitely tiny, if you want to think of it. How tiny? Actually has a name in math, it's called an infinitesimal. And that could solve the problem, because if h is a number, any number that it's not 0, I can put it here. Now, how do I write in math something very, 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 very close to 0, but not quite, because I have a problem otherwise? Well, that, instead of writing on that, I call a limit. I'm getting to it without reaching. The limit of what? Of h tending to 0. Of this expression, what I'm searching for. Okay. This that we just arrived to here is the base of all differentiation. Actually has a name. Because remember, what was I searching for? I was searching for what is derivating. Derivating is trying to find the gradient of any tangent to a function. If the function is not straight, of course, those gradients are going to change, but I cannot touch them, at least in this function, to any point I want. So I want the rule. How do I get it? I now have a formula, and we call it, yep, the derivative equation. Or, because we just got it using what we knew before derivation, or differentiation, remember, they are the same word, differentiation by first principles. Now, this formula here is the base of all the units. If I know the numeric expression of this function, I will be able to substitute it here and get the expression for my derivative. Now, the next step is going to be actually doing an exercise to see how we use that. But that is going to be another video. So I hope you find this instructive. Thanks for watching.